What do all these numbers have in common? That's correct. They can all be written as fractions. Or you can say they can all be written as the ratio of two integers. Any number that can be written as a ratio like this is called a rational number. For a long time, philosophers and mathematicians thought that all numbers were rational, and if you lived in ancient Greece, you would probably think so too. Pythagoras and his followers held this idea sacred, and any challenge to it was considered blasphemy. The discovery of irrational numbers is credited to Hippasus, who in the 5th century BC discovered a proof that the square root of 2 was not a rational number. When he presented his proof to the Pythagoreans while on a boat, they threw him overboard and he drowned at sea. So in honor of his ingenuity and plight, I will now show you a proof of the irrationality of the square root of 2. We will use a proof by contradiction, where we assume the opposite of what we're trying to prove, and any contradiction based on that assumption will render it false. In this case, our assumption will be that the square root of 2 is rational, that it can be written as a fraction. And if this assumption leads to a contradiction, that will prove it false. Let's also assume this fraction is already in lowest terms. It cannot be simplified further. Now let's square both sides. On the left side, squaring a square root just cancels it out and leaves us with 2. On the right side, squaring a fraction just means that you square the top and the bottom separately. Now multiply by q squared. So on the left side, we have 2q squared. It doesn't matter what q squared is, but the fact that it's being multiplied by a 2 means that the entire left side of this equation is even. Multiplying anything by a 2 will make it even. And of course, if the left side is even, and the two sides are equal, then the right side must be even as well. So that means p squared is even. If you square an even number, you get an even number. And if you square an odd number, you get an odd number. Because p squared is even, that means p must be even. Any even number can be written as 2 times some integer. For example, 6 is 2 times 3, and 10 is 2 times 5. So p will be 2 times m, or 2m. Let's plug this in for p, and if we square everything in the parentheses, we get 4m squared. Now let's divide both sides of this equation by 2 and simplify. On the right side, we have 2 times m squared. Remember, 2 times anything is even. So the right side is even, which means the left side is even. And if q squared is even, then q must be even. And since q is even, we can write it as 2 times another integer, 2n. So p is 2m and q is 2n. Let's plug these into the initial assumption that the square root of 2 is rational. It's tempting to cancel out these 2's and move on, but let's stop for a moment and think about what this means. The initial assumption was that the square root of 2 can be written as a fraction, and that the fraction p over q was in lowest terms. But 2m over 2n is not in lowest terms. It can be reduced or simplified. We've reached a contradiction, which can only mean that the initial assumption is false. The square root of 2 cannot be written as a fraction. It is irrational. This means that its decimal representation, like any irrational number, will go on and on forever without stopping or ending in a repeating sequence. That means somewhere in this number is your phone number, social security number, date of birth, zip code, and any other number you can think of. Thank you for watching. If you enjoyed this video, you can support my growing channel by hitting like and subscribe. And please leave a comment letting me know what you think.